Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about bearings. So let's dive right into it. Well, first we have to understand what exactly is the problem. The reason why we have to utilize bearings is you have to understand this one thing. In any mechanical device ever conceived by humans, friction is the enemy at this point in time. So what does that mean? Now friction can destroy anything. Now that's a okay kind of issue. Is like you build a boat, sea can destroy it. You build a windmill, wind can destroy it. Almost everything can destroy it. What makes friction very problematic is it has a feedback loop. What does that mean? Assume it this way: you have a metal shaft like this. It is going through a hole in a wall, like basically a ship wall you have, and you have a rod going through it. Here's the deal: the rod is big and thick and everything is working fine. You have a little bit of oil around the hole, so everything is lubricated, but there will still be some friction. You can never reduce friction to absolute zero. You can only reduce it. So there's friction. Now it heats up, of course, because the energy is being wasted as heat because of friction. Now the moment it starts to heat up, the main shaft starts to heat up, it expands a bit. That puts more pressure on the basically system, and that causes even more friction, which expands it even more, and then it can literally end up in a scenario where it seizes up simply because of the frictional heating. So that's the whole point. It has a feedback loop, and some cases the friction can be so devastating that whole dams can be destroyed because of this, because the turbines that are spinning here, well, they have an optimum RPM range. Basically, if they are in that RPM zone, they are awesome. The moment they start to go below or above that, they become unstable. In those sort of time, if you are utilizing normal non-dampering bearing, they will vibrate so much, they're flat out, it will destroy your building. And if you are talking about a 100-ton metal object spinning at high speeds, start to vibrate. Let me put it this way: there is no concrete or steel or bunker material ever strong enough to withstand that. So flat out, it has happened in past where a turbine ended up in an unstable scenario, started to vibrate, destroyed the whole dam. So be very mindful about friction. It has a feedback loop. Basically things that were like, okay, it can manage it, it itself can make it so bad where it's like the system that you designed is like with cooling and all that, just it could easily get overwhelmed, and it's like, no, your whole equipment was destroyed. And it can destroy almost anything. Friction, heck, if you have enough friction or enough time, you can even grind away diamond. So flat out, it can destroy everything. And this is one of the things that you have to understand. If you build a mechanical system, it's a lifelong battle. It's not something where you're gonna like, okay, I have this issue, I'm gonna solve it, and then I'm gonna home. No, there is no solution. It's a lifelong battle. You have to keep doing it. And whenever you talk about maintenance, like that's the whole thing people talk about now. It's like why solar is much cheaper and much more widely used than wind. Is like because wind has huge amount of maintenance. So what the heck exactly people in maintenance are doing? That's the primary thing they are doing, is making sure the friction value is kept under check. How they do it, that could differ. They could be talking about oil, greasing, making sure there is no dust particles, cleaning up the whole equipment or whatever have you, but the end game is always dealing with friction. That's a lifelong battle. And if you want to understand what exactly happens in a basically bearing, you have to study a specific branch of physics which is known as contact mechanics, because you ideally, the worst thing that causes friction is sliding motion. Basically, if you have things that are sliding on top of each other, that's the worst case scenario. What you want is point contact. Basically, you have big thing, it's just touching at a very small spot, very small spot. You never want that spot to be bigger than a, like, mathematically as small as possible. So that's why railways are so efficient, is because even though while they are heavy, their contact point is very small. So the amount of area they are contacting, where they are contacting the metal wheel is contacting the metal rail, that's very small. That's almost like one rupee coin, very small area. So that's the whole point. And whenever you want to understand it, how the heck interaction at that point happens, you have to study contact mechanism. Now, what are the core architectures of basically bearing? Well, it generally have four components. Now again, more can be introduced or less can be had, but like generally all bearings ever made generally will follow this architecture. You will have inner race, basically inner part, and then that's the part that you will spin. You can even call it rotor. Then that part will have a groove for on the other side, basically a smooth shaft for your shaft input, and basically groove for rolling elements. Now rolling elements would generally be there, but there will be spacing. Basically, there will be a bit of space between each rolling element. Now that creates an issue, is that if you just let rolling elements be there, they will clump up together and they will damage your system. So we utilize what we call cage, or sometimes called as a retainer. Now this sole job of this puppy is to make sure everything is spaced apart equally. So for example, if you have 8 balls and they're supposed to be like 5 millimeters apart, the cage is the equipment that's going to make sure that happens. So these bearings don't end up colliding with each other. They have to be in exactly same place, exactly equally distributed. They always must be equally distributed. Otherwise, if they clump up in any place, they could cause uneven loading of the equipment, and then your equipment will be destroyed. Then you have lubrication and sealing, because right now you have things, rolling elements have cage, but you still have to understand this aspect. Dust is a grinding element. Basically, if you have anything moving on top of anything else and you put dust there, it's literally gonna grind away. Now you may be like, okay, this is like hardened steel, very hard, and it's like nothing's gonna happen. Yeah, not in one go, but like over time it will. So even normal dust over time can do that. And you have to utilize lubrication even in this sort of scenario. Of course, it consumes less if you had just a shaft on shaft, but you still need lubrication. And lubrication has this bad tendency, they like once the dust gets into it, it becomes sludgy, and more dust gets into it, and when it goes even more sludgy, it basically can gunk up to a point where your 10,000 horsepower engine could seize up simply because of a bad bearing. Then we have outer ring, which is the stator part. It attaches to your basically hull or whatever have you, basically things that is not moving. So these are the four core elements. You do not need more than this. This is always you need. And primary friction comes from is the basically sealing is very difficult on bearings. Now, rolling elements is the thing that allows bearing to work as intended. So we generally utilize, or the most common thing is ball bearings. Now, the reason we utilize ball bearing is one thing is simple, is that ball has the smallest amount of contact area. Basically, if you have a surface and you have a ball, the ball is only touching in a very small spot. So that spot is like, because a sphere is always a pointed object. From a contact point of view, it's always as small as possible, like it's almost a small point of view. So it works amazingly. In terms of frictional output, it has very low frictional output. So you can have a ball that is contacting the inner race in one location, outer race on another location. That's it. There is only 2 points of contact. And of course, how many balls you have, let's say 8, 10, whatever have you, and that many point of contacts you have, and the surface area of total that point would be very small. Like you get, even in a big well-built bearing, the actual surface area would be barely few centimeters square, barely. So that's awesome. However, because it's a point loading kind of scenario, it does have the consequence. You cannot make metal strong enough, or any ball that is rigid enough where it's gonna be like, I'm gonna put 10,000 ton through this and it's not gonna deform. Like if you put 10,000 ton on, even on the hardest steel or material that we know, it will simply dent it. You will end up getting stuck. So we have to like, for more than enough scenarios, ball bearings are good enough. But if you are talking about a scenario where you have to use heavy loads, basically if you are talking about something that is GG heavy, like a freight car or railway locomotive, things where it's like serious amount of loading, then you have to utilize what we call roller bearings. The primary reason for that is roller bearings are a cylinder. So cylinder contact point of view is a line. So in a mathematically perfect world, ball bearing will always have a point of contact. Perfect world, cylindrical bearing elements like rollers will have a line contact. So because of the line element, it has the ability to, like how tank tread works, basically it distributes the load. Tank is very heavy, but it does not sink into the ground even on soft ground. The primary reason of that is distributing the load. So that's the primary reason we have two types of bearing. In most of the scenario, ball bearings, GG, don't even think about it. Roller bearings are only used when you have lot of load you have to go through, and you want to make sure that the system can last long enough. So in contact, from contact point of view, you have a line to deal with when you are talking about roller bearing. So that's why roller bearings are generally used on heavy equipment. So your bicycle will most of the likely, it will always have ball bearings, but when you talk about car engines, they will generally have roller bearings. Now, bearings can be utilized in multiple configuration. Basically, they could try to do multiple things. Based on those things, you will have different kind of bearing system. So you have a normal standard, what we call radial bearing. This is the simple. You have a wall, you have a shaft that is spinning. That's it. This is a simple perpendicular motion. This is the simplest type of system. It works. It is good in every regard, but it's not best in any regard. Basically, if you are putting this in a truck axle, it will not work, because there are two loads in truck axle. Basically, first, very high load of gravity itself that has a consequence. It might end up digging into the race, and then whenever truck is cornering, it has a lot of lateral force that could literally rip apart the bearing. So this will not work that. So this is more than good enough for lightweight load. And again, ball bearings are rated kind of equipment, so you can find a ball bearing that is like, well suited for your load. But if you are talking about a scenario where you have, rather than rotational load, you have a scenario where it could go either way, you will not want to use that. Then in those sort of scenario, you want to use angular contact bearings. Now these bearings are basically roller bearings, but instead of like perpendicular, they have a cone to it. Basically, this is how the cone is. Now benefit of this cone is that you cannot push it through. So if your cone is like this action is limited and you can easily spin. Awesome. But here's the side effect. The moment, what will happen if you pull it like this, it will pull out. So you will never utilize angular bearings one way. You will always have two facing against each other to lock it. Now what's the benefit of that? Now imagine the same truck axle, you have a lot of weight going downward. Because of the roller elements, it can dump that load without damaging the inner race and outer race. So that's awesome. And because it's angular, even if you take a high speed turn, as in like 20-30 km/h turn, it has a lot of tonnage load acting against it. In those situations, this bearing can still deposit that load from the axle to the chassis without any issue. It can still manage that. It won't be damaged. And that's why, because you have to have two, because in some scenarios, like if you're taking a right hand turn, one bearing will be bearing the most of the weight, in left hand turn other will be bearing the most of the load. So that's why angular bearings are like found surprisingly more places than you would realize. Then we have thrust bearing. What if instead of perpendicular motion, what if you have parallel motion, things going like this? In those sort of scenario, you're going to utilize thrust bearing. Now thrust bearing is generally utilized in scenarios where you have big chunkus things moving on top of each other. The biggest example I could think of when you have big things moving on top of each other, that is generally battleships, where they have gun turrets which are in like hundreds of tons to 2000 tons. Those are moving on a, like a system. Even tank turrets start to look lightweight compared to that. So thrust bearings are utilized in those sort of scenario. And generally they are roller bearings, because again, ball bearings may not have enough surface area to dump that load perfectly. And then you have slider bearings, generally used for CNC machines, so basically computer numeric controls, be it 3D printer, be it CNC milling machine, be it lathe or whatever have you. So all you are trying to do is make sure no matter what happens, whatever the motion system is, whatever the axis of motion is, you never have sliding elements. You never want this happen. You always want rolling element. You never want sliding. So a linear bearing, wherever you see like a Prusa printer or things of that nature, all this thing is trying to do is just basically have the balls touching each other one after another. You never want it to basically slide on top of each other, because if you're gonna slide it, no matter how much lubrication you put into there, over time it's gonna heat up, and that heat will push out the oil, and then it will end up destroying each other. So that's how we have primary configurations of the bearings. You have radial, angular, thrust bearing. Or you could have a scenario where you can utilize all of these, because each of the bearing have the benefit. Like example, the least amount of rolling resistance is found in radial bearing, the most amount of stability is found in angular bearings. So you could have a scenario where, let's say you are talking about a rocket engine's turbocharger, you could have like on the ends you can have basically roller bearings to make sure angular roller bearings, so it does not vibrate laterally too much, and basically normal rolling elements, because it's space wise is very efficient. So you can have a scenario where like steam turbines, they have surprisingly large amount of bearings. Like they have bearing assembly, there are multiple types of bearing in that. So they're like, this bearing section is handling lateral motion, this bearing section is handling up down motion. So, and this bearing, other good bearings would be specifically built just to handle pressure, so it can seal up against a system. So that's how load bearings are handled. Then we have to understand what we can expect in the future. Well, bearings are priced surprisingly differently. You can find a bearing that are used in aerospace industry, same dimension, exactly same dimension, exactly same material, but the moment you want to see the price difference, it will like $1 to $1,000. Like, why the heck that kind of price difference? Simply because of geometry. Now geometry is one thing to design in a CAD or computer, is like, okay, this is how my element's gonna work, everything is fine and dandy, but another to achieve that in mass production. So for example, ball bearings are a physical device that we built, so it's perfect but not absolutely perfect. Now the difference between perfect and absolutely perfect, or as perfect as we can make it, there is a very giant amount of time, machining, tools you have to spend just to make it a bit more perfect. Now making it a bit more perfect translates to a lot of improvement. So you can easily find bearings same size made by multiple manufacturers, and one would be like barely good enough, another would be like good with some long life, another would be like, whoa, this is butter. And even though dimension could be same, geometry is a very critical scenario in that. And geometry can also have mean other things also, like let's say the engineers did a feedback loop and they're like, do the raceway is not deep enough. sometimes that happen. So raceway, they may design it to be deeper, or they could have different groove design. These little things have a lot of impact. So that's the first thing you will do if you want to, like, you are dealing with bearings. Try to find a higher quality bearing, and you will find surprisingly a lot of benefit just by changing the bearing. You don't have to change material, grease type or anything, just better geometry will give you. And the end game, what do we actually want to achieve, is dry bearing, basically a bearing that does not have lubrication. Lubrication is really problematic, simply because it goes away over time. So whatever lubrication you have is basically gonna leak over time, and if you have grease, it will break down, like on a chemical level it will break down over time. So fundamentally it has an expiry date. Even though everything in your bearing system would be flawlessly working, you have to keep servicing it. People don't want to service their equipment, and that reduces life. So for example, the clock that is being built by Jeff Bezos, the 10,000 year long clock, it flat out would not be possible if you are utilizing any bearing that has lubrication. So flat out they are relying on basically ceramic bearings, and same bearings are now being used in every satellite. So whenever they have basically solar panels that are shifting, or gyroscopes that are spinning, in those scenarios they are utilizing this, because flat out well, space does have the benefit of not having any dust in it. So that's one good thing. And because of ceramic is harder than steel, it on a point of contact it has less deformation, so there has gives you the much longer lifespan, and your grease will not break apart due to cosmic rays. So that's the whole point. You want a good performance, you try to improve the geometry. You want like this, the end game is making completely dry system, but right now we cannot do that. And you can easily find, like in high-end racing bikes, is that generally there will be steel inner way, steel outer way, but the balls would be, rather than used of basically steel, it would be ceramic. Ceramics is much harder. It is brittle, but it is harder, so meaning it does have the ability to transfer much more load without deforming. So it does have some benefit. Consequences, it is have the side effect of being brittle. So if you are talking about utilizing on steam turbine, everything is fine, and the one bad vibration of through earthquake or other, that whole bearing block will go poof, turn to dust. So fundamentally that's the reason why you don't see ceramic bearing used everywhere. Now I have found one gentleman who did basically fidget spinners. Yes, I know, fidget spinner, and he shows the demo of all that, like one steel bearing, one steel system with ceramic balls, and another completely ceramic system, and you can see the difference of effect on that video linked down. It's kind of interesting to see just by changing the materials. So this was my presentation on bearings. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.